So now next we are showing that what are the ways you can initialize a constructor here. So there are different ways to initialize a constructor. So for example, this is the one way you can call the constructor. So let me write here that constructor. Okay. So this is one way we can call the constructor. So let me write it here. So this is the one way you can call or create a constructor. So this way you can call the constructor or create an object. Another way is, let me write again it. Again, we can create one constructor. So this way you can also create an constructor. Now let me again paste it. So this is also one method to create one object of the constructor. Now let me copy these things and we are going to print the values here. So we can call P1 object, then we can call P2 object, then again I can call the P3 object. So we have created the object using the different method of creating initialization, and we are going to print the value. So let's run. So it is running. Now I can call the class 1. So you can see here that different way of initialization is giving the same result. So this is the initialization method. Let me turn off it. Next one is very important topic, that is we are going to understand the class 2 pointer. So how you can use the pointer for a class, that aspects we are going to study. However, before that, let's understand what is the pointer. So we should have idea about what is the pointer, kind of variable that stores the memory of created variable. Now I take a variable with the name of p. So this variable is a kind of a pointer variable. Okay. Now we can store the address of a into this pointer. Okay. So if I info of a, so I can write it as a p. Okay. So in C++, this is known as the address of a. So that this marks signifies that this is the address of a. Now this is the printing the address that is stored in the p, and p is a kind of a pointer variable. Now if you want to know that what is the p pointed to, okay, so the address which you are showing, what is the value it is pointed to? Pointer p has value. So if you want to know that what is the value it is storing, then we have to put star. So this star p signifies so star means it signifies that it is pointed to a variable. Okay, so let's run it, then you will understand the concept. So it is showing that the address of a is 1 and it is pointed to a value that is a 3. Okay, so this is the address of a, that is the a variable, it is 1 and the value it is pointing is to 3. Okay, so now if you want to check whether this is showing the correct result or not, so we can print like this also. So let's see that both are giving the same result or not. Okay, so again you can compile, again we can run. So you can see here that both are giving the same result. Okay, so the variable a equal to 3.0 is stored somewhere with the memory index 1, and when we are again calling this pointer star p, it is showing the variable what is shown here. So this is the pointer to a variable. Now we are going to understand the pointer to a class. So similar way you can create the pointer for the given class. So suppose we are creating one class, that is the pressure cal p1. We can create a pointer of the same class. Okay, so similarly as we are doing here, similarly we can create a pointer. Okay, so we can store the address of p1 in this pointer. Okay, so we have created one object p1 and we have created the pointer of the same kind. Okay, now we are storing the address of this object into the pointer ptr. Now here is the catch. If you want to call the method of this class, there are different way you can call the method. So for example, so let me copy this. So now if you want to calculate the pressure using this pointer, okay, so there is slight difference. You can use that ptr, this method. This is going to call the pressure well method of this given class. Okay, so this is the one method you can call the members or the method of the given class. There is another method, so you can write it as a star ptr. Okay, so when you call the star ptr, it is directly pointed to the object you have created, and now the from that object it is going to call the method what you want. Okay, so this is the another method of calling any functions and any method of a class. Now let's run and see what is it is going to give the value. Data and then wmake, so full it is going to work. We can ignore the warning. Now if I run the class one, oh sorry, class one, we can see here that both are giving the same value. So this is the call the concept of the class to pointer. I can also enclose this. So I'm just giving the brief idea how what are the things in OpenFOAM. So class to pointer is a very important concept and has been vastly used in OpenFOAM. And when we are going to see examples, then we will see this concept. To understand the more concept about the class, I have created another folder that is the class 2. And now we are going to do further modification here. Next concepts what we are going to understand, that is the operator overloading. Okay, sometimes what happens that you want to do operator like addition, subtraction or field multiplication on different kind of the class. Like suppose you want to add two complex number. Okay, So suppose this is the one complex number, and suppose this is the another complex number. So if you want to add, and if you write, uh, suppose this is the a equal to, this is equal to b equal. So if we write a plus b, so the compiler will be confused that what the user want to do. So whether I should add a what 1 plus 2 or 2 plus 7, that is not understood by the compiler. So in such case, there is a concept of the operator overloading for a given class. Okay. So first, let's create a class. So suppose I can write class complex num. Okay. So I am going to create scalar, that is the R is suppose uh, real part, and I is suppose imaginary part. Okay. So I'm creating a class having R is imaginary part and I is the imaginary part. Okay. Now we can go to the public. Okay. So here in public we can create a different kind of a constructor. So for example, I can create this constructor, and other I can create the constructor where we can take the value of the scalar count. So this is the another constructor. Now we can create the operator. But before creating the operator, first let's give the definition of the constructor. So complex num double semicolon, and again complex num, and first I'm defining the null constructor. Okay, so null constructor maybe r equal to, we can give 1.0 and I equal to 2.0. Okay, so I think I have already given you the definition of the null constructor. And in another constructor, we can take two value, that is the kind of scalar. Suppose I am taking scalar a comma scalar b. So I can assign this value as a and this value as a b. So this is the another constructor. Now we can define the operator overloading. Okay, so we want that the real part will be added to the real part and the imaginary part will be added to the imaginary part. So first we can specify the operator here. So I can write complex num. Now I can call the operator. So suppose we are going to do the addition, and then I can say that I want to add another object of the similar kind. Okay. So this is the similar kind of object I want to add. Maybe I can call the reference of that object. Okay. So it still needs to be right. I've just specified the, I've just given the declaration here. Okay. Now this is a kind of a method. This is similar to the method. So remember, this method has a return type. Okay, so for example, earlier, if you remember, let me open the class one. So earlier you remember that when we were declaring a method, for example, I have created a method this set value. So this set value I have created, and remember here that here the return type is void. So we were specifying the void here. Similarly, Here the return type is complex number, so we are going to specify the complex number. Okay, because this is the type of return we are wanting here. Okay, so this is a similar to the concept of the method or functions, you can say. Now we are going to call the operator. So this operator we have going to call. Now we are going to take the complex num as argument, where we are taking the reference, and suppose we are going to take press 1. Okay, so this is the short form of the pressure 1. So I am taking this argument. No, sorry, this I can take as the number 1. So I am taking one argument that is the number 1, and I am going to add two number. Okay, so here what we will do, we will create one object. Suppose I am creating complex num of 1.0 comma complex num n1 is equal to 1.0 comma 2.0. So this is the one one object I am creating of the complex number. Now again I am create another class, that is the n2. I can take value like 4.2 comma 3 1.3 something. So this is the another object we are adding. So we want to add this. Now if I add n1 plus n2, so I am already taking one object, and one object I am passing as argument. Okay, so this I don't need to the pass as argument. This class I am this object I am passing as argument. Okay, so the result, maybe the result will be the type of the complex number only, because we will get another complex number after adding these two values. So I can write as the result. Okay, now the result dot this r value, this r value will be r plus num1 dot r. Okay, so result is another object of the same class whose r value will be addition of the r of this n1 class plus addition of r of this n2 class. So n2 class we are passing as argument. Similarly, we can write for the I, and this here is the imaginary part. Here also it will be imaginary. We can return the result. So see, this result is of the same kind, that is a complex num. That is why we were written here as a complex num return type. Okay. Now we have created these two value, and here we can store the addition into some value result as the n1 plus n2. So we are storing here n1 plus n2. Now we can info the result after addition. So we can write here that the addition of complex. There will be one imaginary part, one real part. So maybe we can write it as a first real part result plus then result dot I into Okay, so these things I think clear to you. Let's compile and see that whether there is an error or not. So there are some syntax error, like here we need to write a scalar. So it is saying result is not declared here. So we have to put here RES and RES. Now I think it should work now. Again there is some issue. So it is saying that R is the private member. We cannot access here. So R8 is the private number we can access here. So to use this, we need to declare this in the public. Okay, so you can do the operation on R and I, but out of this class, you cannot call the values of R and I. So maybe we can declare as a public, then we can print the values. So remember, we can do the operation, but to print the values, we need to declare it as a public. So here you can see here that the additions of these two complex number is 5.2 plus 3.3. Okay, so 4 plus 1 is 5.2 and 3.3 value will be the imaginary part. So I think this operator overloading is understood by you, and in OpenFOAM you can see that there are lots of operator overloading is done because you works under the different kind of fields, like you want to add the vector quantities for the velocity, and there are many things that is done in OpenFOAM. That's why this operator overloading is very important from the perspective of OpenFOAM. But I have just given the basic about what is the operator overloading. Thank you to all of you for watching this video.